Hello everyone, welcome to my channel where we are learning DSA concept wise. So let's have a look at today's problem. Today's problem is to find the number of provinces where we have given an undirected graph with v vertices and we need to find the number of provinces. First, let's understand the problem with an example. Let's say we have this graph. So when we look at this graph, we can say that we have two connected provinces. One is this and second one is this. So we need to find this number of provinces. In this graph, we have two provinces. As we are mastering the concept, so I will relate this problem directly with the DFS traversal. For DFS traversal, you can watch my last video on DFS traversal. Link is given in the description of this video and also now reflecting in the right top corner of this screen. So first let's understand our approach. First we will start from the first vertex, then we will apply the DFS traversal on this vertex to get to know how many vertices are connected with this node, and we will mark all the vertices which are connected with this node as visited. Then we will further look for the unvisited vertices and will apply DFS on the vertices. So let's understand this deeply from this graph. First we will start from vertex 1 and we will mark it as visited, and from 1 we can move to 3. So we will move to 3 and we will mark 3 as visited. From 3 we can move to 5. So we will move to 5 and we will mark 5 as visited. Now from 5 we can't move to any another node. So we will move back to 3, and from 3 we can't move to any another node. So we will move back to 1. Now we have traversed this graph completely. So we will increase the number of provinces. As initially it was 0, so now it is 1. Now we will look further for the unvisited nodes. So we will find that 2 is unvisited. So we will reach to this 2 vertex and we will mark it as visited and will apply DFS on this node. From 2 we can move to 4. So we will move to 4 and will mark it as visited. And now from 4 we can move to 6. So we will move to 6 and will mark it as visited. Now from 6 we cannot move to any another node. So we will move back to 4, and from 4 we cannot move to any another node, so we will move back to 2. As now we have completely visited this graph, so we will increase the number of provinces. Previous it was 1, now we will increase it by 1, so it will become 2. Now in this graph we don't have any another unvisited vertex, so we will say that we have 2 provinces in this graph. Now first let's understand the pseudocode, then we will implement the code. First we need a graph. As we know that we can store a graph in a 2D matrix or as an adjacency list, let's have a adjacency list here. And we need number of vertices. Let's have num v, and number of vertices are v. We need a visited array and the size of this array will be v plus 1. I already explained in my video on DFS why we need this visited array in detail. Let me explain it little again. So we need this array to keep the track of the visited vertices. We need one more variable, that is number of provinces, to keep the track of number of provinces in this graph. Initially it will be 0. As in DFS traversal, we apply DFS only on the starting node, as there was only a single connected graph. As here we can have more than one subgraphs in the given graph, so we will use a loop to apply DFS on the unvisited vertices. As I explained that first we will start from the first vertex, then further we look for the unvisited nodes. So let's run a loop here that will start from first vertex. Here first vertex is 1 and it will iterate to number of vertices. Now we will look for unvisited vertex. So if vertex is unvisited, then we will apply DFS on that vertex. And after that we will increase our number of provinces variable. And here we will have a DFS traversal code. That's it. In this way, we can count the number of provinces. Now let's implement the code. So here we have given an undirected graph as adjacency list and number of vertices as v. So here what we need extra one boolean visited array, and the size of this array will be v because here the first vertex is 0th vertex. We need one variable, let's say numpro, to count the number of provinces. Now we will run a loop that will start from the first vertex and will go up to the number of vertices. And in this loop, we will look for the unvisited vertex. If the vertex is unvisited, then we will apply DFS traversal on this node. Let's pass graph, node, and this visited array. And after that, we will increase number of provinces. Now let's implement this DFS traversal method. We need this adjacency list, graph, the node, and this boolean visited array. First, we will mark this node as visited. So we will set this true. Now we will visit the neighbors of this node. So to visit the neighbors of this node, we need the list of neighbors of this node. So let's get the list of neighbors of this node. Now we will iterate over this neighbor list and we will see to which neighbors we can move from this node. So now run a loop. Here we will check if the value at this index is 1, then it means we can move to this neighbor. So let's check the value at index I. Let's check is it 1, and we also check is neighbor visited or not. And if neighbor is not visited, then we will apply the DFS recursion call. That's it. And here we will return the number of provinces. Now let's run this code. This is fine. Now let's submit this. This is also fine. The time complexity of this solution will be big of v plus 2e as this is a undirected graph. And in case of directed graph, the time complexity will be v plus e. And the space complexity will be big of v because here we are using this visited array. So that's it. Thanks.